Today we're going to cover pages 4 and 5 of our Chapter 2 notes packet. So turn to page 4, Section 2.4, Adding and Subtracting Rational Expressions. First we'll look at those that have the same denominator. So the steps are to add, subtract the numerators by combining like terms of the numerators, copy the denominator, simplify the resulting fraction when possible by factoring numerator and denominator and dividing out or canceling common factors. So, number 1, for our rational expressions here, all three have the common denominator of 7b. I always like to copy the denominator first. Okay, and now combine like terms in the numerators. Well, we have 9a subtract 1a is 8a, plus 3a is 11a. Now we look, can we simplify this fraction? No. So that's our answer. Number 2, common denominator x minus 4. I'm going to copy that. Combine the like terms of the numerators. 4 subtract x just stays 4 subtract x. Now we have our single fraction. Can we simplify it? Yes, notice that these are opposites, right? So we divide these out and replace it with -1. So this is equal to -1. Number 3, same denominator, copy it, x squared minus 36. Combining the numerators, x minus 6. Now we need to simplify the fraction. The denominator can be factored. That's a difference of two perfect squares. X plus 6 times x minus 6. And the numerator x minus 6 we bring down, and the x minus 6 divide out. So our answer is 1 over x plus 6. Number 4, common denominator, a minus 2 squared. Numerator, 3a minus 6. Now again, we take this rational expression here, can it be simplified? And to do so, we factor. There's a GCF in the numerator of 3 times a minus 2. And our denominator remains a minus 2 squared. And remember, if you want, you can write that as a minus 2 times a minus 2. And a minus 2 is divided out. So our final answer here would be 3 over a minus 2. Next, number 5, I'll copy the denominator. X squared plus 3x. Combining like terms of the numerator. Now be careful here. We have 2x squared subtract x squared plus 9. I'm going to bold the subtraction because I have to remember I have to subtract each of the two terms that follow that subtraction symbol. So this is going to be 2x squared subtract 1x squared is simply 1x squared. Subtract a positive 9 is minus 9. Now we have a single fraction. We need to simplify it if it is simplifiable, which it is. This is a difference of two perfect squares, so this factors into x plus 3 times x minus 3. And our denominator has a GCF, x times x plus 3. X plus 3's are common to the numerator and denominator. They divide out, and we're left with x minus 3 over x. Now, moving on, when we have different denominators, well, you know, when you add or subtract fractions, you have to have the same denominator. So if we have different denominators, we have to find the least common denominator, which is usually a factor of each denominator. First, if the denominator is a factorable polynomial. Write equivalent fractions with the same least common denominator add, subtract, and simplify. Okay, so we look at our denominators. We know we need to get a common denominator if it doesn't have one. So I look at 4x and 8x. Go to the larger one. Does 4x divide evenly into 8x? Yes. So 8x is our least common denominator. So our LCD is 8x. So we are going to write down equivalent fractions with denominator of 8x. So I want to take 3 over 4x and write its equivalent with a denominator of 8x. Well, what do I do? What do I do to 4x to get 8x? I multiply it by 2. So I do the same to the numerator to get 6. And here, just bring down the numerator of 3. Okay, so now we have subtraction of these two fractions. They have the same denominator now. We'll copy the denominator 8x, and then 6 subtract 3 is 3. And that cannot be simplified, so that's our answer. Look at number 2. We have denominators of 3y and y. Does y divide evenly into 3y? Yes. So that is our least common denominator, 3y. So we're simply writing equivalent fractions with a denominator of 3y. This one, just bring down the numerator. And here we need to multiply y by 3 to get 3y. So I do the same to the numerator. And make sure you're distributing. This is 3 times y plus 2. So that would be 3y plus 6. We have the same denominators now, so copy the denominator. And again, this is subtraction, so I want to subtract. 4y subtract 3y is y, and 3 subtract 6 is negative 3, or minus 3. So we have y minus 3 divided by 3y. This cannot be simplified, so that is our final answer. Number 3. We have denominators of x, y squared, and x squared y. Well, okay, go to the larger one. This has an x squared and a y. This has an x and a y squared. So we need each the greatest number of times, in which case we need x squared and also y squared. So x squared, y squared is our least common denominator. We multiply this by x to get x squared, y squared. So multiply the numerator by x. So x times x is x squared. X times negative y is negative xy. We need to multiply this denominator by y to get x squared, y squared. So we multiply the numerator by y. So we have xy plus y squared. Copy our denominator, x squared, y squared. And, well, at least we have addition here. So we have x squared, there's no other x squared term. We have negative xy plus positive xy is 0, and then plus y squared. You cannot factor x squared plus y squared. So this expression cannot be simplified. So that's our answer. Number 4. Here we have denominator of c minus d and c plus d. They don't have anything in common. C minus d doesn't divide into c plus d. It's similar to having something like if we were to have 1 over 3 minus 1 over 4. There's nothing in common there. So our least common denominator here for 3 and 4 would be 12, their product. Well, the same is the case for these two binomials. Their common denominator is going to be their product. So we write c minus d times c plus d, and leave it in factored form like this. You do not FOIL it. Minus c minus d and c plus d for our denominator. Okay, now I need to multiply this by c plus d. So I do the same to the numerator. 1 times c plus d is c plus d, and I need to multiply this by c minus d. I'm actually multiplying by 1 in the form of c minus d over c minus d. Okay. Copy our denominator, c minus d times c plus d. And now remember, it's subtraction. Again, I'll always bold that, especially when we have two terms that follow our subtraction. C subtract c is 0. D subtract negative d, that's going to be d plus positive d, is 2d. This cannot be simplified, so that is our answer. Page 5. Number 5. Okay, we look at our denominators. A minus b, b minus a. Now wait a minute. These are opposites, right? So I like the way a minus b is written. B minus a, what if I take out a negative 1? I would have negative b plus a, which is the same as a minus b. Okay, so in other words, this denominator here can be written as a minus b with a negative 1 out in front. But let's just bring that negative 1 up to the numerator. So I have a squared over a minus b plus negative b squared over a minus b. Same denominators. Copy the denominator. Now a squared plus negative b squared is simply going to be a squared minus b squared. Can this be simplified? Yes. This is dots. This is a difference of two perfect squares. A plus b times a minus b over a minus b. And the a minus b's divide out, so our answer is a plus b over 1, which is simply a plus b. Next, number 6. Sometimes your denominators, you want to factor them first, as is the case in number 6. If I look at this denominator, x squared minus 2x, there's a GCF of x. We factor out x, and I have x times x minus 2 for the denominator in factored form. Okay, now this appears to be larger than just x minus 2. Does x minus 2 divide evenly into this? Yes. So this here, x times x minus 2, is our least common denominator. So let's write down equivalent fractions with denominators of x times x minus 2. We need to multiply this by x. Again, do the same to the numerator. We'll have x squared plus 3x. And here, just bring down the 10. Copy our denominator, x times x minus 2. And now combine x squared plus 3x, subtract 10. Now, we've got our single fraction. We need to simplify it if it can be simplified. This is a trinomial. Are there factors of negative 10 that add to positive 3? 5 and negative 2. So this factors into x plus 5 times x minus 2. Copy our denominator, and the x minus 2's divide out. So our final answer, x plus 5 divided by x. Next, number 7. I'm going to factor each denominator, x plus 6 times x minus 6. That's difference of two squares, and this has a GCF. X times x plus 6. Okay. I need each factor the greatest number of times it appears in a denominator. So I need an x plus 1, an x minus 6, and I also need this x. X plus 6 times x minus 6. And I'm just going to write the x out in front of those two binomials. Okay, so we want to write equivalent fractions with denominators of x times x plus 6 times x minus 6. What's missing here, we need an x. We multiply the denominator by x, do the same to the numerator. So this is 2x. Multiply by x minus 6 is what's missing. So our numerator here is x minus 6. Okay, we've got the same denominator, so let's copy it. Again, we have subtraction and then two terms that follow, so be careful. 2x minus 1x is x, and minus a negative 6 is plus a positive 6. And the x plus 6's divide out. So this is equal to 1 over x times x minus 6. Number 8, factor those denominators. Difference of two perfect squares. And the trinomial, factors of negative 35 that add to negative 2 or negative 7 and positive 5. Again, we need each factor the greatest number of times it appears in any denominator. So x plus 7, they share an x minus 7, and x plus 5. So we're writing down two equivalent fractions with that common denominator. What's missing above here is the x plus 5. So we need to multiply by x plus 5. So 7 times x plus 5 is 7x plus 35. And here, what's missing? We need an x plus 7. So multiply by x plus 7. 6 times x plus 7 is 6x plus 42. All right, same denominator, so let's copy and combine like terms of the numerators. Now remember, we have subtraction here. So 7x minus 6x is x. 35 minus 42, negative 7. X minus 7's are common. They divide out. So our end result, 1 over x plus 7 times x plus 5. Pause the video. Try the next one. Okay, the denominator here, that's not factorable, but our third one is. Difference of two perfect squares, 2x plus 1 times 2x minus 1. Okay, so we have three fractions here. And our common denominator is going to be, yes, 2x plus 1 times 2x minus 1. So taking each of the three fractions and writing equivalent fractions. For our first one, we need to multiply by 2x plus 1. So 2 times 2x plus 1, 4x plus 2. Next one, we need 2x minus 1. So 2x minus 1. And we're all good here, so just bring down the 2. And again, we have subtraction, so be careful, especially with this one. Copy the denominator, 2x plus 1 times 2x minus 1. Okay, here we go. 4x minus 2x is 2x. And 2 minus negative 1 would be 2 plus 1, which is 3. And now 3 minus 2. 3 minus 2 is 1. Positive 1. And 2x plus 1's divide out. So our final answer, 1 over 2x minus 1. And this concludes today's video.